Hello everyone, welcome to Love and Philosophy. This is the third post in 1 week. I had these conversations many months ago, but this is how they all finally come together. I've been trying to understand what empowerment is, and I guess I mean that in an everyday sense, but I also mean it in the sense of algorithms, artificial intelligence, Shannon information theory, measurement. If you have no idea what I'm talking about, don't worry. I didn't really understand this either not too long ago, and I still don't, which is why I'm doing this podcast, to try to understand it. Claude Shannon and information theory is at the heart of pretty much every device you're near right now. Whatever you're listening to this on, your computers, our phones, everything has to do with this digital computing, which deals with a way of transferring information. It's pretty much that process of my voice coming into your world right now. Claude Shannon made that possible. He reconsidered the way that we might change one form of energy or communication into another one. I would have a look at the diagram of Claude Shannon. If you just Google Claude Shannon information theory, you'll see this wonderful little diagram of a receiver in the process of encoding and decoding to get to the receiver. This is a conversation of me trying to learn about empowerment with someone who works in robotics, Dari Trendafilov, and he is trying to help me understand it. And we talk about how it relates to a lot of the other themes I've talked about on this show, like affordances, because Gibson is a big inspiration there. Empowerment's looking at this quantity that's information-based so as to characterize how efficient the perception action loop is between the organism and the environment. But in this case, it's not an organism, it's a robot. So the robot and its environment. So the real sticky, hard question is, what's the difference between an organism or a living body and a robot? But it is important that we realize we're all using words in different ways. Information, empowerment, entropy, inference, belief, all these are really important words, and they mean really different things depending on which world you're using them in. I'm bringing it up here because it's part of what this conversation is trying to understand what I feel like gets really, really blurry when we're working in technology. For example, Dari, who talks with me here, is working in robotics, and I'm very interested in robotics, and the empowerment measurement is something that he's working with as he works with swarming robotics. So that's fascinating. But as you'll hear in the conversation, we quite often switch between talking about humans and these words as they're used for humans and the robots, which are really different things, actually. I mean, empowerment is a measurement in a very literal sense, which I'm trying to understand in the way it's used in developing artificial intelligence. Empowerment in the field of artificial intelligence is formalizing and quantifying the potential an agent perceives that it has to influence its environment. So it's the measurement of channel capacity, of how much the robot, for example, perceives it can influence its environment. It's the robot's intrinsic parameterization relative to its encounter. It's a utility function that depends on the information gathered from the encounter. So how can it gather information from its encounter so as to increase its control within that interaction? I think that's kind of what empowerment is measuring. It helps develop patterns so as to increase control. So it's rewarding what we would call intrinsic behavior, which means the robot will inherently be rewarded for exploration and curiosity, because the more of its environment that it encounters, the more it's going to increase its ability to control those kinds of regularities. This is really similar to the way psychologists talk about intrinsic motivation and empowerment too, because that also has to do with the body, our ongoing living activity, and that we are doing things to satisfy our internal desire for control or wanting to have control. But also intrinsic motivation could just be something like hunger and wanting to satisfy your hunger. So perhaps the more you can explore the world, the more likely you are to find something that will be edible. Either way, empowerment's measuring the potential of this agent, this robot or this organism to align with the environment such that the environment itself becomes a way for it to actualize itself. It's almost imprinting itself in the environment and the environment in itself through this perception action loop of interaction. And I think that perception action loop is the information. And the technologies are the translators of that perception action loop. I think information is really a translation process. It's not a thing. We tend to think of information as a thing that's being moved through the world, but I actually have come to think of it as a translation. The process of translation, which is the movement from, for example, my voice right now into your ear. So there's not one thing that's moving from me to you right now, but there's a process of translation that's happening from me to you right now, and that is information, in my point of view. That's not the point of view of information theory as it stands right now. And that's what I want to understand better and discuss. A lot of Bayesian approaches are doing an inverse. They're working in ways that you can infer the so-called internal structure, or maybe the way that we are as living life, the way that we're coming to align with or increase our control of the encounter, so to speak. You can kind of infer this from the way that the external world, the data that world generates. So it's going kind of backwards. So you're starting to infer the structure of the external world from the data of that world. So it can go both ways, I guess, in empowerment. You can understand how life, the living body, is controlling the world, and by controlling the world, that means increasing its ability to structure it. And you can also understand how the world is controlling the body or the mind, which is to say, structuring it. So I'm really interested in the way patterns and regularities of the world might empower those of the body, and it goes vice versa. The body is also empowering particular regularities that are experienced in the world. And this might be something that empowerment can help us to better understand at the individual level, but also at levels of robots swarming, or birds swarming, or humans acting in crowds. In any case, empowerment, as it's used by people like Dari here, is a information-theoretic quantity that's usually motivated by some desire to make the sensorimotor loop more efficient between the agent and the environment. We sometimes confuse and say it's the robot that's trying to become more efficient, but really it's whatever that robot's affordances point to, which is the human who has created it or that wants it to do something. It's really for those, that's really where the empowerment is. It's not in the robot. But the empowerment measures how well that's happening via this technology, this agent environment system, and these stochastic transitions. How much then does that technology, that agent, that robot have over the environment that it's being tested within? Two words that come up a lot are controllability, which is the influence on the environment, and observability, which is the measurement by the sensors. And that's the controllability and observability has to do with this ongoing encounter, or what we call the environment. You can't take those things away from each other, so that's the interaction. This ongoing interaction, sensorimotor loop between the body and the environment. And we substitute the robot into that, and we discuss it as if it's the robot's sensorimotor loop, but actually that robot is an extension of the scientist or the engineer or whomever is focused on it or whoever has created it. It's actually an extension of their sensorimotor loop. I think that's what gets confused. So we're actually studying the empowerment of the scientist or the researcher, not the robot. But the measurements that are being taken are also called the empowerment measurements, because that robot is itself part of our sensorimotor loop as the researcher. So we've done something very similar to what happens when we talk into a telephone and our voice is translated. We've just sort of talked into this robot, so to speak, with our controllability of the environment. We've sensed that into the robot, or somehow tried to translate that into this robotic model, represented it there, so that we can then look at that sensorimotor loop from a different point of view and translate it hopefully into the environment. Who's the receiver of that? What's the destination? In this case, it's the same researcher, or at least the field of study that the researcher is studying. So it might be, for example, if it's with the Nokia phone, as Dari says, then the Nokia company and the researcher have extended their affordances into this robot so as to see how that robot might increase the controllability of the sensorimotor loop in that environment such that it will afford them better, because it will mean they can give their customers a better utility function. It's also important, some of these studies I found that this only works when you have a very particular recognizable semantics. So that also speaks to this idea that the robot is already an extension of the researcher or the research project. So the affordances aren't the robot's affordances, they're the affordance of the researcher or of this field of study. It only makes sense as long as you have set that parameter, that landscape of potentials. So that's why it's so confusing and also so fitting to use these words like intrinsic motivation and empowerment, because in fact, in a way that we aren't always very clear on, it actually is about the empowerment of the research project or the researcher or the field of study. And it is intrinsic motivation, it's just that we've represented it in the robot and we're now measuring it with very particular kinds of maths and algorithms that we call empowerment and intrinsic motivation. It's a bit of the doubling that Thomas and I talk about, which doesn't mean that we've doubled life. We're not a double body or a double person, but we've done this heuristic of doubling so as to better understand ourselves or understand this process, this looping between ourselves and our encounter. But it's a very limited one because we've had to set this very limited scope of semantics so as to be able to study it. So it's a very limited and controlled representation of one part of our sensorimotor loop with the environment. But in doing that, we can understand it better in the same way that in writing something down, we might understand it better, or in drawing a diagram. It's just that we've now been are able to do that in a more complicated way in the creation of a robot, for example. So we say it's about the robot's potential ability to influence the environment by this capacity to imprint information into that environment and then perceive it through its sensors. And that's the representation. All of that is an external representation, like a little model of our own sensorimotor loop. But it's also part of that sensorimotor loop. So we've literally sort of extended it and created this little model. But the voice, so to speak, like when the voice goes into the telephone, in this case, we're still putting the voice into the robot. And by voice, I really just mean whatever it is that we're trying to understand. We are the sender of that into the robot. But the affordances always point back to us as the researcher, or us as the company, or wherever you want to put the scale. And that's what often gets confused, I think, and what I was trying to better understand with Thomas in the conversation about the body. And it also gets to this very essential question, which I think is the real question at the heart of this, which is, again, what's the difference between the living body, or the body, and the material technology or machine, the phone or the artificial intelligence or the computer or whatever you want to call it. And I think that the difference is in the affordances. I talked about this with Carl Friston too, and he seemed to agree. We talked about the thermostat, for example, and that the affordances of the thermostat are not its affordances. They're the affordances of whomever might be using that thermostat in order to control their own sensorimotor loop. So I've been thinking about Boolean logic and George Boole, who had this idea that we might be able to put things into a kind of binary logic that would help us understand thought, that would actually give us a kind of math of thought. And I think that's very interesting, because what we often think it is that we're trying to solve what thought is, but in fact what we're doing is representing thought externally so as to create ways to better understand the process that is thought. So it's not that we've created something that thinks. Instead, we've represented our own thinking with something, and the affordances always point back to us. So actually Boolean logic and Shannon information theory, and also Shannon's early paper, the master's that he did, where he basically came up with the binary digital computing code that we are also familiar with. We often think of that as if we're getting a computer to think, but what we've really done is, and it's a remarkable thing to have done, is we've found a way to represent this ongoing process by which we come into different states of life, what we call thinking, and we found a way to represent that in the most simple form so as to understand what is redundant and what is not. And in so doing that, we're increasing our efficiency for further translation and communication. But we haven't actually created technology that thinks. We've created technology that represents our thinking. This is a really, really different thing. And I actually think that once we understand that the affordances of that representation or that model, that robot, actually point to the researcher and the specific semantics of the research interest, which are the researcher's affordances, then it actually starts to make sense. The robot is not the one that has the affordances. It's an extension of some sort of research semantic program. Therefore, the affordances point to those bodies, that researcher or that group of researchers. So I go into that more in my research diary, trying to understand it. And for now, I'll just leave it. And those of you who want to try to learn with me, this is just a conversation I'm sharing with you, with someone who is generous and try to open up the world of robotics and the measurement of empowerment with me. I'm trying to find a happy balance here between people who've never heard of such things, people like me who are trying to learn of it, and then others of you out there who are already experts. If you want to comment on the YouTube video of this or the YouTube audio of this and share some points in a friendly way that might help us all, you're welcome to do that. I would love it. So here we go.
Hi.
Hi, Dari. Thanks for being here. It's great to talk to you today.
Thank you, Andrea. Thank you for inviting me. It's a pleasure for me to be here.
Good. So we met because of a conference in France about complex systems. And after the conference, actually, you brought up this wonderful, which was then at the time new to me, the idea of empowerment, which we are going to talk about in terms of reinforcement learning and machine learning and so on. But to start, first of all, maybe we could just hear a little bit about you. You work in swarm robotics and intelligence. Would you like to tell us a little bit about, in general, your scope?
Yes. Currently, I work indeed in the field of swarm robotics, artificial intelligence, and more precisely in applying the empowerment measure to different contexts and scenarios in the field of swarm robotics. For example, one scenario in this domain is collective perception. Another scenario is a site selection task, and there are further and further scenarios. So we try to apply the empowerment measure to provide generic predictions for swarm performance and enable the design of different decision-making controllers for the robotic swarms to operate in a decentralized and autonomous manner. So this is currently the goal of my research.
That's great. I just wanted to set it up so people know we're coming at this from that background in a way, because empowerment can mean so much to so many different people, right?
Yes. Yeah, I know.
Especially listening to this.
The term is actually quite overloaded. As I noticed yesterday, I gave another talk here at the Sorbonne, and actually this question popped up exactly after the talk that, wait a minute, empowerment, it means so many different things. And we are just using it as a very narrow technical term. It's like a function, mathematical function, and it's probably misleading because in different contexts it could mean, of course, it's used in sociology, in humanities as well, so in politics as well. So and people tend to have slightly different meaning, but here, as I will talk about it, it will have purely well-defined mathematical content. So
yeah, it's kind of a sexy word. It kind of draws you in, and it can kind of mean a lot of things. And actually, the way it's used, you sent me a bunch of papers to sort of help me get an overview, and there's no way we'll get through them all today. But as I was looking through these and trying to get my head around all of this, coming from a more philosophical background. So in your work, are you working with multi-agent reinforcement learning mostly, or?
Well, yes and no.
Okay.
So currently, yes, we are involved in swarm robotic studies. So this is kind of a multi-agent environment. So
Okay.
yes,
But
but
that's one form of reinforcement learning, and then there's also reinforcement learning that's just with a single agent,
yes,
and that's
yes.
a more kind of normal way that it's used,
Well,
or?
yeah, that's the standard way how it began and it was invented. But it was then applied to multiple agents, and the more agents you get into the scene, the more complex it gets. So in a sense, in swarm robotics, I'll get back again to that field that I'm working on currently. The difficulty in swarm robotics is to enable multiple agents perform dynamic tasks and operations simultaneously without any guidance from control system for a central control system and self-organize to perform the task and achieve the goal, which is a completely decentralized multi-agent system. And in the case, it collective intelligence task. So the term is also very well used, collective intelligence, because they are
Collective intelligence, yeah.
yes, all agents are intelligent and they write on and they perform and they behave independently from everybody else, whilst they still communicate and driven by a goal in the
Okay.
end of the day. So they yes, so they do like humans. We have collective intelligence, right? When we do things together and we try to emulate this in robotic agents too.
I think so, but some people would, that whole idea of collective intelligence and what even intelligence is, you can go down many rabbit holes. But just for the sake of this, an agent, in your case, do you mean an actual kind of robot, an independent robot?
It's one independent robot. So if we take the case of bees, for example, it's one bee. So we also try to emulate nature. So we learn from bees and ants, and there are also swarms of independent agents. Yes.
And when you say the environment, that's just everything that's not included in what the agent is? Or
Uh,
does that include all the other agents for each
it
individual
it
agent?
could be, yeah, that's a very
Okay.
good question. So the environment can be anything outside the swarm, or depending how you look at your model of the world, it could be also if you look from the viewpoint of one single agent, then everything else, including all the other agents, could be considered as environment. But it could be that only everything else except the swarm is the environment. So you see the difference
So it depends where you're going to
depending
set the scale.
depending where you put the viewpoint
Okay.
and
So
how
and
you
that'll
center
matter
it.
for if learning is happening or not, right? Depending on where you
Yes,
set the
yes,
scale. And
yes,
what's
yes,
learning? Is the
yes.
swarm
And what
learning, or is the individual agent learning, right?
Oh, yes, exactly. Very good point. So that is exactly what is the difference, because if you set the model to be a single agent, then you learn the policy or the behavior of a single agent. But if you set it for the swarm, then you optimize the behavior of the whole swarm at once. Yeah, so
Okay.
that's exactly.
And then by learning, right? So we've got this agent, we've got some kind of environment. It's going to depend where we set the scale, but we can definitely set the scale where the agent is, where the X environment is in terms of the
Yes,
actual math and everything.
yes.
But then the learning itself, how would you describe that?
So the learning process is of course driven by some task. So there is a goal for the swarm and therefore for the individual robots to perform something collectively. One simple example is the collective perception, where the agents explore a swarm of agents explore a field, a site, or you can imagine it can be an agricultural field or it can be a minefield, and the agent try to count the number of the bugs in the agricultural field or the number of mines in the minefield to discover them. But so it is exploring the two-dimensional environment or the field on the ground simultaneously and deciding the quality of that field. Is it very damaged or it's good quality? For example, so this is just a very, very abstract example, but the point here is that a single agent, and that's what's important in swarm robotics, that a single agent is not able to cover the whole field, or it would take a very long time, and it would not last so long to detect the quality of the field on its own. So that's why a group of agents can do this faster, cooperatively, but they have to communicate and they have to share their knowledge, and therefore they need a sort of decision-making mechanism, how they exchange opinions by communicating with each other locally, and then arrive at a consensus, at a conclusion in the end of the day, and solve the problem and decide that the site is badly damaged or the site is good enough. So if there is something to work on or to perform on this site. So
Okay, I'm gonna stop you there just for a second
yes,
because this is where it gets kind of confusing for me. So if I was thinking
okay,
of something like rats, right, which is used a lot in neuroscience.
yes,
And of course, you know, there's in the literature, of course, the rat needs to explore the space and all of this, and then you know, relative to how it's going to solve the task and so on. And there's a goal and all of
yes,
this, and it sounds a little bit like that, right? Like they have to explore the space
yeah.
and there's a goal, but it's not quite like that, right? Because what you've programmed them in a certain way. Can you help me understand kind of what you've given these agents such that they then are going to kind of do something new with it?
So in this particular example that I mentioned, collective perception, the agent or the robot have a simple sensor for detecting the ground, the quality of the soil or the ground, the floor, and that's what they can detect. They can move freely. They can randomly explore the environment, and then they just read the quality of the ground underneath.
So it might
And
be like a little
it's
camera
local.
or
Yeah, it's a little camera. Yeah,
right.
exactly. That's a
Okay.
little camera. It's a
So it's
sensor that
trained on images of what it's going to see with that camera
yes,
sort
it
of.
collects. Yes, it collects
Yeah.
the data from this camera, from the images, and by collecting the data, it forms an opinion of the quality of the site, and it changes that opinion because as it moves, it finds different patterns of different quality around as it walks in the field, and it changes its opinion. But it also changes its opinion by sharing information through communication with its neighbors, with the close neighbors. So
Mhm.
if the close neighbors are telling each other that the quality is very low of this field, then they kind of persuade each other. So they convince each other that the quality is low, and that's driving the consensus to convergence of the swarm. But nevertheless, the exploration is driven by this sensor, which is deriving the images of the field. But because this is local, they cannot see the whole field at once. They can only
Mhm.
explore one little piece of it at a time, and they have to move around to explore other pieces of it. So this would take forever for a single
Mhm.
agent. So by communicating and exploring at the same time, they share information, and in a way, they collectively integrate or aggregate that information.
They're almost like we were talking about scales before, so they almost
Yeah.
become sensors themselves, which
Yes,
yeah,
exactly.
okay.
Yes. Oh,
For the larger collective, yeah.
exactly.
Yeah.
Intelligent sensors. Yes.
You've input things in before. They've been trained on many, many different images that they could encounter.
So in this, because this is quite simple example, they
Yeah.
actually no real images for training because the quality of the site is binary. It's black or white.
Okay.
So it's really blank. But what is learned here and what is trained is the decision-making mechanism. So how they decide when to change their opinions and how they aggregate that information. So this is in our case, this is trained using evolutionary algorithms, and it evolves actually a neural network. So this is a neural network, which is a black box, as you also know, which drives the the decision-making control mechanism for the individual robot. And that put together on a swarm scale drives the self-organizing behavior that will collectively solve the problem. So here the learning is how to share and how to exchange information and change the opinions of each other. So this is what is automatically generated. And if we train that with evolutionary techniques, as I mentioned, we use machine learning for that, and we don't know the actual mechanism because it's, as I mentioned, it's a black box.
Okay, so
Does it answer your
yeah,
question?
yeah, it's great.
So
And
it's
what you
not
just
standard
yeah,
machine learning as you thought, I think it was, but it is the same
yeah.
thing, essentially.
Well, what gets confusing is sometimes there is no robot, right? And so
Yes.
it's just then it's kind of an algorithm as the agent.
Yes, yeah, then let me iterate on this because probably that would be useful. So here we are talking about the behavior of the individual agent, of the individual robot. So there are real robots that we are using for this. We just develop using evolutionary algorithms, we develop the neural network that we install into the agent. So the agent has an algorithm. So it's like an algorithm which decides what the agent does when it reads black or white, and when it reads from the communication with the neighbors, when it again reads black or white, how does it integrate that information? So this is the neural network or the algorithm that is evolved, and that is the black box in this case.
Okay.
So that is the decision-making mechanism only.
So I'll say something and then you correct me, right?
Okay.
In this very general example, and I'm generalizing too, the swarm is a lot of different agents trying to come to a conclusion about the space, and then they're going to do that through communicating. Is the problem of overfitting that each individual agent will just sort of fit their own algorithm to the algorithm that they're communicating with? Or like what's this kind of I'm trying to understand why something like intrinsic versus extrinsic motivation, to get towards empowerment.
Yes, okay. Well, when we talk about intrinsic motivation, we mean some drivers that are inherent to the agent itself, which, for example, we have typically homeostasis as one biological metaphor for that, because this is not driven from the environment, from outside, but this is internal for the survival of the organism that is necessary. And similarly, in robotic systems, we try to apply this same principle of intrinsic motivation that is independent from the external world. And any driver that is coming from outside, then that is extrinsic. So when you have something, that is driving you. So for example, you can think about hunger. It's an intrinsic motivation. So this is entirely within a single organism. So that process.
Well, see, but now we've flipped to the biological.
Yes, I'm sorry.
No, it's not your fault, but that's the papers do it, everyone does it, and I understand these things in real life, or even in philosophy or neuroscience or biology, the way they're used. But I don't know if I understand this correct, but maybe you can go into the history a bit. But I seem to think that machine learning and all of this robotics, in terms of robotics, is sort of developed on an extrinsic or with concern about the external. Like there's a goal and you have to reach it, and so it doesn't matter that much about something like the equivalent of hunger, right? But there were some problems with that in terms of maybe with the swarm intelligence not working as well, or I don't know what, but intrinsic motivation, which is basically modeling something like hunger, or the robot itself having its own kind of algorithms that apply only to it and that only it can kind of work with through the sensors. This is something different, but I don't understand it yet, really.
Yes. I will set this right now because I understand the point, because we were talking about a few different things at the same time now. But to make it clear, when we talk about intrinsic motivation, this is one of the motivations and the driving force for empowerment. So I think because you have read the papers about empowerment and you have seen intrinsic motivation there many times, hopefully. And empowerment is such a driver. Let me just explain. Because when you apply empowerment to guide an agent, a robot or whatever, or organism, you are trying to maximize the influence of that agent over the environment. And that is something inherent or internal. And that is why empowerment is an intrinsic motivation drive, because it forces the agent to maximize its influence over the environment by applying actions and perceiving the effect of those actions. So that is what actually empowerment measures. And by maximizing this level of control over the environment, the agent places itself in a better position to survive. And that is driven, so that is not driven by the environment or by external forces. This is driven purely by internal forces for the agent.
How much one robot can influence its own environment, or how much agency that robot has on that environment would be the
So that is the drive for the agent itself, and as empowerment is defined, it is purely measuring it's purely measuring the level of control an agent has over its environment. And if the agent tries to maximize its level of control, tries to maximize its empowerment, then therefore it is driven by only purely by intrinsic motivation. So that is why intrinsic motivation is mentioned so much in those papers. So it's not related to machine learning. So we have to separate now this two.
Okay, that's very good. And how is that different from before there was a such thing as, or if you don't use intrinsic motivation, like it has to do with the goal, I guess, or I don't know what.
Well, yes. So the goal is something external to the agent, and if the agent needs to set targets and achieve goals, then there is usually a reward function, and that is used in reinforcement learning to drive the process. But so there are different perspectives in this, also in machine learning. So the important thing is that when you when you try to look at the natural drives in nature, and you try to mimic them, as I already mentioned, bees and ants and other organisms, they're really very well studied nowadays, especially the simple organisms, which are easier to study. And principles from their intrinsic motivation and from their biophysical process being implemented in machines and in robots. So that is why intrinsic motivation is gaining so much traction also in research and in robotics. But so there are different concepts, and there are different applications for intrinsic and extrinsic motivation. So yeah, we should not mix them. Yeah, I just wanted to say that intrinsic motivation has been evolving over time as a way to mimic nature.
Okay.
Because microorganisms, so people, humans, animals, microorganisms, they all have intrinsic motivation for survival, and that is a basic principle that is driving the behavior from foraging, feeding, to mating, to everything, and that is the principle to reproduce and survive, and those are a purely intrinsic motivation processes. So that is something behind many robotics achievements nowadays as well. But yeah, I'll stop here now.
And it's sort of independent of the task too, right? So there's something very interesting. I mean, can we kind of think about the big picture of why robotics is so important? And when you're making these swarm robotics and you're studying intelligence through robotics, do you think of yourself as sort of modeling what's going on in nature so as to try to understand nature? Or is there any kind of orientation like that for you?
Both. Yeah, a very good question, by the way. Thank you. So, because I should have raised that topic as well. So, as we try to understand nature and we try to replicate it in robots and in machines by creating these theoretical or artificial models, which we implement in machines, we also can reverse the trend and understand better what nature is doing, because we can do simulations in machines. By using these models, we can run simulations, and by seeing the performance of these models, the performance of the natural models in artificial simulations, we can compare to the observed behavior of the natural systems, and we can pipe that feedback into the biological studies, and then help observe better and better natural systems. So this is a two-way process, actually. So that's why, did
Yeah,
it
great. It's great you say
answer?
that. Yeah, no,
Yeah.
that's perfect. And that's kind of the point too, because it can get very confusing about the difference between the process itself and modeling the process, first of all, but also I'm trying to understand the bigger picture for you too, you as a person, but also what your field is doing and what's motivating the work. Why empowerment? Where you came across it, and so unpacking that, maybe we can start to unpack the history of empowerment too. Or
Okay,
yeah.
yes. Okay, very good question. Because then I will say some words about how I came across and why empowerment. So let's get that clear. So as I mentioned, I started in the field of human-computer interaction, and when I first
Did you get a degree in human computer interaction or like
yes
computer
yes
programming?
yes actually I did my PhD research in human-computer interaction.
Okay.
And that's when I was looking for some potential measures that could help human-computer interaction research.
Why were
As-
you interested in that? Did you just happen to kind of come across it, or was it something you'd been interested in for a long time, or what was like? Was there a
well,
problem you wanted to figure out?
I was working at Nokia Research on mobile multimodal human-computer interaction, so human-computer interaction for mobile devices, smartphones, etc. So there we have used the usual methods and tools used in human-computer interaction and usability testing, and we have realized the limits and the difficulties that every researcher in the human-computer interaction faces, because there are various theories and schools of thought in that field, uh,
I guess
which
that's
are
what I want to hear. What was like because for those who aren't familiar like me with that whole area, what's a problem that you hit your head
yeah.
against early on that you might want to solve, or that you're still trying to solve? Or
Yeah. I will come to that now, because so there are different methods and there are different disciplines actually studying this field, like psychology, sociology, physiology, engineering, it's computer science or linguistics. So you have people from all different backgrounds. And so it's quite complex research community, and they're all concerned with studying and improving the factors that influence the effectiveness or efficiency of human-computer interaction. But what is used in that field is usability testing, usability specifications and metrics, and they are used to ensure consistency and the compatibility when we create these satisfactory user interfaces. And that is typically the goal of UI design. However, the usability engineering provides tools and measures which guarantee the user goals and needs. But as the market becomes increasingly more discriminating, this term of usability or ease of use becomes very often too vague, and it needs more rigorous evidence to back claims like easy to use or user-friendly interface, because we have been working on improving user interfaces for mobile devices, and mobile devices small, so it was difficult to come across the exact paradigm at that time. And from that, we thought that we need some more formal models and more sound theories and principles to enable this whole process of research that will improve the current usability studies. And because this usually is lacking in HI research, I when I was looking for some potential methods and tools, I came across empowerment. And during my PhD research, I looked into this formalism of empowerment, or the principle of empowerment for characterizing human performance. Since it was quite novel at that time, it was quite novel information theoretic measure that taps directly into the perception action loop of dynamic interactive systems, and that's what I needed for mobile human computer interaction research.
okay, let me just be kind of a little bit ignorant or something. Because so if you're basically creating technologies or working on how to create better technologies, is
Yes.
that kind of fair? And then you want it to be usable, which basically means that the consumers are going to easily be able to interact with it. So that's the human computer interaction. When you pick up a
Yes.
phone, the way that
Yes.
you interact with it is everything about how successful that technology is going to be, but also like for the company, but also for the person who's using it. But what I don't really understand is how that connects to the algorithms or to this intrinsic motivation. Maybe you can help me with a bridge there of why would you start looking at empowerment if you're trying to think about the usability of
Okay.
a machine device for a human?
Yes. Well, okay, then I'll explain that now because yeah, I think that we need some motivation for this because the view now of a user interface for human-computer interaction, the view rests that the user behavior is about the user controlling their own perceptions. So we have interaction, we have actions and feedback as we press buttons on the touch screen, and then we get feedback from that. And so these are actions and perceptions. So this closed loop interaction.
Yeah,
But
that kind of
when you have a human in the loop, then there becomes a perception action loop. Well now it becomes an integrated system because you have a machine and a human, and that's why it's called human computer interaction. And it depends both on the computer and both on the human because um, there is a closed loop. The human has sensors like eyes and ears, and it has actuators like fingers and voice. It can speak as well. And it's interacting through the microphone or through the speaker and through the touch screen. And it can also get vibrotactile feedback as a feedback. It can get audio alerts or audio icons. And it gets text on the screen, it gets images on the screen.
Just taking generally, for me, this sounds like the machine, which in this case we're talking about a phone, but all of this is kind of cartoon examples, but that we need the machine in the interaction. The machine needs to be able to work with similar patterns in a way, in a kind of continuous way with the human for the communication to be seamless. So somehow the patterns of interaction need to be continuous. Does that make sense?
Yes,
Okay.
perfect sense. And now the focus of my work in this field was actually to develop a measure that could qualify or quantify the effectiveness or the user friendliness of user interface from human perspective. So it
Okay,
was
now
not
I get
like
it. Now I
it was,
get it.
yeah,
Yeah.
yeah. So it's not about designing robots or designing artificial humans. It was about measuring or capturing the essence of a human computer interface, how usable it is, because previous usability, as I mentioned, they're very, very different and vague. Sometimes they cannot be replicated. Usability, I think, mostly conveys some satisfaction, user satisfaction in the end of
But
that day.
actually in this kind of work that you're doing and in terms of how it's gonna scale up into other things like the swarm robotics, there's actually a very real connection there between why we would want to care about the way that the phone or whatever the machine is, its algorithms, right, or its motivation in this sense, because there's this dynamic interconnection. But you were going to tell me how you got into empowerment from here, right?
Yeah, yeah, and yeah. So it starts from this view that the user's behavior is about them controlling their perceptions, and since the perception is tangled up with specific possibilities of action, which are called affordances by Gibson.
Mhm.
So such affordances are the possibility for use and interpret the actions which are offered by the environment to the embodied agent. So
Wonderful you bring up Gibson.
in
Were you reading
in
him? Were you
this,
aware of that back
oh
then
yeah,
or yeah.
yeah. This
Okay, so that was
yeah.
all part of your
In yeah,
yeah.
HCI, he is yeah one of the seminal reference. I think
Yeah, I
you
just interviewed someone who was one of his students, actually, Harry
mhm.
Heft, who writes a lot about affordance, and it's a really different way that they're using it there. But that doesn't matter. What I'm interested in is just that you were already really influenced by that
Yes.
early on. Yeah.
Well, as I mentioned, this field is very much mixed with researchers and they're psychologists and sociologists, and they come with references from Gibson, Wittgenstein, and others.
Because that term
And
affordance is
you,
perfect for what I was just trying to describe, because that is that interaction, right? It's not in the
yes,
environment or in the person,
yes,
it's the interaction. It's the human computer interface or the whatever, that
yes,
the dynamism of that.
exactly. Okay, so you get it now because actually that is the primary motivation for from my work in that field. That was at that time an ability to quantify affordances in a principled way, just to benefit the design of HI systems. So
Wonderful, fascinating. So that was your motivation in a way.
yes, because
Okay, well, that and then so you were kind of dissatisfied with what you had, the tools that
what
you
was
had.
there.
Yeah.
Yeah, right.
And
Yeah.
how did you find empowerment? Was it already when did it start?
The first publication of empowerment was 2005. So it was about that time. So I started a bit later my work on human-computer interaction, but empowerment was already published, and that's what I came
Do you
across.
remember when you came across it?
2008, I think.
In what context were you trying
I
reading?
was
You just
I was in a collaboration project with researchers in the University of Glasgow, and that was brought up to my attention by Professor Roderick Murray-Smith, who later became my PhD supervisor.
Oh wow.
So that was how it came together.
Okay. And maybe now we could say what empowerment even is in a way
Oh,
about it. Or-
yeah. Well, if we want to give some brief description for the original principle of empowerment. So, as I mentioned, it was introduced as a universal task-independent utility, which is defined by the channel capacity between the agent's actions and the subsequent sensory observation. The empowerment is the channel capacity. So if I put it with direct terminology using Shannon channel capacity between the actions of the agent and the subsequent perceptions. So
Okay.
that's channel capacity is maximal mutual information between the actions and the perceptions. And in that sense, it measures, as mutual information measures, the common amount of information between actions and perceptions. So the relevance between actions and perceptions. So if your actions and perceptions are irrelevant between themselves, then it doesn't matter what you do and what you observe, there is no correlation at all. So if we use that term correlation instead of empowerment, so if they're highly correlated, then you are in control of your perception action loop because you know what to expect when you apply an action. You know what perception you will observe in the end of the perception action loop. So, so that is essentially what this mutual information or the channel capacity is measuring because it's maximizing the mutual information between actions and perceptions. And when you maximize this mutual information, you maximize your level of control through this perception action loop. So it's a measure of perceivable control because you perceive an observation from the environment through which you are applying your actions. So it's a closed loop through the environment. So that's why it is very important to emphasize that the perception action loop is between the agent and the environment. So agent applies an action through the environment and receives a feedback from the environment and applies another action. And that unrolls over time. So you can do this over many time steps. And then you can ask for the perception after n time steps. And there we talk about n-step empowerment, for example. If
I don't know
you
what that is, but keep it.
if you skip the intermittent steps, you just apply actions, but you don't observe anything, and you observe the feedback from the environment just after n time step, then you have a quite long horizon
Mm.
in this perception action loop, and of course, the longer the horizon, the more options you might have, but you never know.
Did
It
that speak to
depends.
this idea of potential? Because in the papers or in a lot of the writings, there's these distinctions made between, well,
Actual and
I think of like
potential.
this, yeah, and so you can measure kind of almost like patterns or potentials. This is showing you kind of patterns and potentials that can be applied in different situations. You don't have to have the environment exactly the same way, or do you?
No, the environment depends on the task or the scenario, and it's part of the stochastic model. So for the model, you need specification of both the agents and the environment, and that is all up to you. So that is why it's flexible. It can be applied to anything because it is something like a scheme. So that's why we call it as a notion and a principle because it's not strictly defined for some applications or environments. It is just a tool, that mathematical tool that can be applied. It's not guaranteed that it will be beneficial for all cases, but it is quite abstract and universal. Um, it might be, with some tweaking and expertise, it might be applied to almost anything on a certain level, because it's quite abstract. And you also mentioned, yes, so it's just to state that it's measured in a single unit. It's measured in bits, because that is what entropy is actually. That's the background
What is measured?
information
The
quantity.
motivation is measured? Like
Well,
hard to follow.
the channel capacity actually is measured in bits, because it's a communication problem. The Shannon communication theory is
Right.
designed, is defined for
Let's
communication.
say we were talking in these bigger senses about, what is intrinsic motivation and this kind of wider sense. And then this is where I get kind of lost, because if we start talking about Shannon information, we are talking about bits, right?
Yeah,
We're
yeah,
talking
exactly.
about,
Yes,
yeah,
that
so
is the measure. It's a
it's
unique
minimizing
measure.
surprise, more or less, then.
Yeah, yeah,
Would
you
that
can
be
say
that
that.
would that be almost like what the intrinsic motivation model
Yeah,
is
yeah.
helping the agent do, minimize surprise?
If we talk about entropy, yes, you can
Okay.
say yes, yes. Entropy is
But
measured in bits
this
as
is a
well.
model, so it's literally doing it through bits of information, which is different probably than
Exactly,
how it's
exactly.
happening in the real world, but we've used the
Okay.
model to understand the real world.
Well, now this measure is quite a bit of different beast, because it gives you now a measure, a value of bits, which doesn't tell you much, because it's incomparable to other problems, to other models. It depends only on the model. So the point of this measure is to give you a benchmark, so it can so you know the range of this measure for this particular problem. When you design it, you know what's the maximum level of empowerment, what's the minimum, and then within this range, you can benchmark what you get for different solutions, and that's how you can tune your system. For example, your user interface, or your swarm robotics decision making controllers. Um, but it will be all different. So if I say now for this problem, the range of empowerment is between 0 and 1 bit, but that doesn't say too much, because for other problem, it can be between 0 and 1 million bits. It all depends on the model, and that's why it's not absolute. It's all relative to the model, and you cannot compare the values of empowerment in absolute terms. You cannot compare them between different models. They're just illustrative for one particular model and for one particular scenario that you want to study. But
yeah, when is this helpful? I mean, we talked about the phone, or we talked about the robots, or I don't know how to kind of make it into kind of an example that can then help us understand the parameters towards a real life situation. I mean, this will be messy, but something like with the phone, or with if you're trying to understand how you're interacting with your iPhone or whatever, why would that click or put a light on in your head that, oh, this might be a way to go at this problem of understanding this affordance relation? What is clicking for you that's helping you understand something like that interaction differently? If you're trying to understand the human computer interaction between any device, why is that way of looking at it giving you something that without that way you don't have? Do you know what I
yeah,
mean?
yeah, I understand. Okay. Let's say in the example with the phone. So if you're trying to make a case, or a scenario use case of empowerment in the case of a mobile phone with which you interact every day, and you know that there are different factors that constrain the usability of the device. So there are usually different form factors, different sizes, smaller, bigger. You know, the keyboard is quite packed. It can have different characters from Chinese, Japanese, Latin, whatever, different number, and Arabic as well. So operating with, for example, such keyboard with, now we can also consider different people with different finger size, people who can hit 3 buttons at the same time when they touch the keyboard, and that's not really helpful to type a message, right? So this all boils down to usability. So you can add to all. So this we can just term it as disturbances or uncertainty. So for example, you press a button, you try to type a message, and there is an uncertainty which letter will come up, because sometimes you hit the wrong letter because they're too small, or you walk in the street and a lot of disturbances again. So this is noise. So now let's put this all together: uncertainty, noise, disturbances of any kind. So from your sensorimotor system, so your finger, your muscle, which is operated by your brain, but your brain is at the same time guiding your walk on the street. So you are multitasking. So these are disturbances that constrain your abilities to type properly while you're moving, and your hands are moving as well, your body is moving. So it's shaking and whatever, people are hitting you on the street. So there are all kinds of disturbances, noise, and on top of that, we also have system disturbances that are bringing delays, and they're also sensor inaccuracies, in system errors in the software itself. So there are pop windows that come and disturb your typing every now and then you think that you have hit a button, but actually you just close the pop-up window because it was on top of it, right? So this all accounts to the uncertainty in the interaction process. So if you try to model that, and this all affects your measure of control over the interface. Now, if we think the environment as the phone, and that's the interface you're trying to interact with, and if you have a very bad performance, let's say very bad typing accuracy, it is due to low empowerment. Does it make sense?
It makes sense, but what's interesting is this can happen at the algorithmic level, can't it? So like the phone could, in a way, instead of needing me to get exactly everything right, infer from the overall kind of pattern that I've expressed.
Yes.
It can use this algorithm to find that solution quicker, is what I'm trying to get at.
And they are exactly, and they are doing that. They also use machine learning for correcting user errors. That's exactly correct. But empowerment is not the replacement for these algorithms. It is just a measure that encapsulates all these different kinds of disturbances that are just mentioned and listed. All these different types of noise and uncertainty in the interaction process, which otherwise would have to be measured separately by sensor imprecision noise with some units, by communication delays, which are measured by milliseconds or something, by, I don't know, size of the keys on the keyboard, because some are bigger, some are smaller. And these are all contributing to your user satisfaction, or to the usability of user interface, essentially to your performance, typing performance. And if you consider them all separately, then it's not too handy, it's not too useful. Empowerment, if you bring all of these types of uncertainty into the same model, you measure it in the end in bits. It's just a single value. And as I said, if you know the range, 0 to 5 or 0 to 100, let's say in percentage, then you can modulate, you can control the level of user satisfaction by changing, for example, the size of the keys on the keyboard, increase or decrease. But essentially, if you that was exactly the motivation, to understand better the quality of the user interface, and therefore use that information to design better user interface in the end of the day.
That's wonderful, and that makes things a lot clearer for me. And as you were talking, I was also thinking back to the robots that we started with, because you were saying at the beginning how each one can't explore the whole space by itself. It needs everyone else, so to speak. But it also has to sort of communicate with. Does it help you there too to understand how each robot might have its own intrinsic motivation? Sorry, I'm kind of making it a little too psychological, but if each robot is talking to each other and sharing information, is there also a way in which studying it this way, even from your point of view, the way you're studying the robots, this can help you understand what collective intelligence really is happening there? Or what does that bring up for you when I try to bring it back to that, to these different agents who are trying to communicate and your position trying to understand how to make them communicate better?
Yeah, yeah, very good point. Because there is again a two-way interaction between these studies and the natural studies. So we try to implement um, decision-making mechanisms or neural networks into robots to drive the swarm towards some goal, but in the same time, these observations and these swarm models can be used to compare with data that is observed in nature in bird flocks or in fish schools and swarms of ants and bees, because that's where we learn from. That's what we get as a background, and we just try to mimic. But when we implement these simple robotic swarms, we have the tools and also the simulation. So we also do a lot of work with simulated robots because that's much faster and easier. And there you can do much more. And with those models of simulated robotic swarms, you can try to understand better what happens in nature. So because those are models that you can control. So they're system parameters. You can change control variables, and then the behavior of the whole swarm changes. And then you can link it to bird flocks or other natural swarms, and then infer what is actually the behavior or the driving force behind that.
That makes a lot of sense to me then, because I think I was trying to put it into the robot or into the swarm, right? And
Yeah,
actually, empowerment isn't about putting it into it in the sense that I'm talking about. It's about, from your perspective, understanding
yeah,
what you're trying to understand by building that whole system. Because understanding that then sort of increases our agency and our wonder of the world. And from that position, from you trying to understand it, it makes a lot more sense to me, because I can see how that would give you something of trying to understand better how certain changes in the pattern of the kind of intrinsic motivation of one robot could lead to a whole kind of cascade of changes
yeah,
in a way that, like, to go up a scale would itself seem like one intrinsic motivation. Does that make sense? Like the
yeah,
swarm's
absolutely.
intrinsic motivation.
Yeah, 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 and exactly. It's just analytical measure which gives some kind of quality estimation of what's going on, if that makes sense, of the process, and that helps you actually see the big picture because it brings together many things on a higher level, and it can explain, and it can actually make predictions. So the important thing is that because it's analytical, you can compute it theoretically with the system that you have designed. You don't have to run any experiments. You don't have to buy expensive robots
Mhm.
and invest in that. But just by computing the level of empowerment for specific system parameters, for specific levels of the system parameters, you can decide actually what you need in your future robot. When you're building robot, for example, what capacities, what sensor range, what communication range, what camera you want to build in your robot. Because usually swarm robotics, I didn't mention that, is driven by very low cost small robots, which are notorious for being able to break very easily because they're very low cost. But that's okay because there is redundancy in the system because the swarm is big enough. But of course, that is why you try for minimizing all the costs of sensors, all the hardware, because you know that it's dispensable anyway, and you still want the swarm to solve the problem because you have to invest into the hardware something, but you want to trade off the cost versus the performance. And if you can do that in design time, and if you can get a prediction from the empowerment measure, prediction for the system parameters that will solve your problem at this cost, then you don't have to play with real hardware to decide that, oh no, this is too expensive to solve the problem, I should do something simpler. So you understand what I'm trying to say? You
Yeah,
can,
yeah.
yeah.
Yeah, that makes a lot of sense
So
relative
that's
to your
the
work and also how
like,
you got into this and everything.
yeah, that's like the big picture of it. Yeah.
Do you think of yourself as modeling intelligence when
Well,
you're making
it's
these robots?
not really. Oh well, modeling
And
intelligence
I mean
in the
modeling
sense of,
intelligence when you see intelligence in the world. Do you think the birds swarming are intelligent, for example? Or does that word not apply? It only applies.
well, I think it's a kind of collective intelligence. It depends on what we mean by intelligence, of course, because it's a collective behavior, certainly, and because it is very complex. We might say that it needs a certain level of collective intelligence to perform all these shapes of bird flocks without collisions. You know, they're very proficient in that.
Mm,
And that is, yeah, that's
yeah.
incredible. But yeah, I just want to point out that empowerment is not directly supposed to build intelligence. So if you ask me if I'm creating intelligence, not with empowerment. So of course, for the robotic swarms, we build systems that behave intelligently, but they use neural networks, so not empowerment
I don't think you're
entities.
creating intelligence, but I meant modeling it, trying to understand it.
Modeling, well, yeah, it's part of, yes, yeah, well, it's part of the process, yeah.
And by intelligence, I mean, to go to Gibson or somebody that almost any to try to get past that dichotomy, he was trying to get past that subject object way we think of mind, body, and so on. For me, any creature, any being, especially birds and swarms of birds, that's intelligence. But when people hear that word, they often think of it as human intelligence, which means it's attached to some kind of symbols
Mhm.
and it's thinking about itself and all of this, which I definitely don't mean at all. I really mean almost like a foundational problem solving movement, so to
Yeah.
speak. And it seems like you would almost have to go to that level when you're modeling something like a swarm, that you almost have to go to that level of, yeah, whatever that is.
Yeah, yeah, yeah. Well, that's exactly right. So there are different levels in this process, and empowerment is operating on one particular level, as I already mentioned, on the perception action loop level. But of course, yeah, we are aware that there are levels up and down of that. So and which are very important, and empowerment is just like a building block in that process. Yeah.
What's like really exciting for you when something happens in your work? What's like something is it when you figure out a math equation? Is it when the robots do something different? Is it collaborating with everyone around you? Like what
Oh,
feels, yeah.
well, I think in my work, most exciting um, parts have been by bringing together different fields of science and research, and applying models from one field to another, like cross-pollinating different fields, and in particular applying empowerment to different paradigms, which seemingly disparate, but in the end, as I said, empowerment is quite abstract tool, and it can be leveraged to quite many. I mean, in different sciences. I mean, don't mean just natural sciences, but humanities as well.
So empowerment is measuring channel capacity, or somehow the utility is a channel capacity. But I wonder how we relate that to love. What's empowerment relative to love? Does love have a channel capacity? Does our expression of love in the world have some sort of parameters of capacity?